Hi POE students, I'm back with one more example for you. This time I'm going to do number 5. It says a 35-foot long steel rod is subjected to a load of 8,000 pounds. This load causes the rod to stretch 0.266 inches. The modulus of elasticity of the steel is 30 million psi. Determine the diameter of the rod with a precision to the nearest hundredth. Okay, so let me get some just clean sheet of paper. All right, so let's draw a picture. Let's see. Determine the diameter. Okay, I want to see that they say diameter here. So I do know that the rod has a circular cross section. So when I draw my picture, I'll just illustrate that. And this is not going to be drawn to scale. So I have this 35-foot long steel rod. So let's label this 35 feet. And it's going to be subjected to a load. And as we subject it to a load, it's going to deform. So I'm just illustrating that it's been deformed, that we're getting some elongation. And the load is 8,000 pounds. Okay, so here's a little picture for me to start to see what's going on. Let's see, that was this load caused the rod stretch. Let's label this little length right here. .266 inches. Okay, so I'm drawing a picture and basically listing my knowns. Okay, and if we want to put just our symbols, our variables next to that, this is elongation, so delta. This is L, the original length, and this is F, our force. So there's our knowns. Also known is that because this is steel, we had a modulus of elasticity of 30 million psi. That 30 million could be written in scientific notation as well, which would be 3.0 times 10 to the 7th power. So be prepared to see that in either format. Okay, we're asked to determine the diameter of the rod. D for diameter. We don't have diameter generally in any of our formulas, so that makes me think that something else that we weren't given, that's unknown, that we might like to know, is the cross-sectional area. Because that we've used in our formulas, right? And I know that there's a relationship between the area of the cross-section and the diameter of that circle. So if I can find the area, I'm pretty sure I can work back and find that. So I need to look for a formula that would involve the length, the elongation, the force, the modulus of elasticity, and the unknown that I think will help me get the diameter. The equation that I have is the one for deformation or elongation, where we said that delta is equal to the force times the original length divided by the area, the cross-sectional area, times that modulus of elasticity. Okay, and I want to find A, right? Because A is going to be used to then to go back and figure out my diameter. So before I even plug things in, why don't we just rearrange this a little bit? And I'll show that. If I want to solve for A, I don't want A in the denominator. So how about I multiply both sides of the equation by A, just to cancel it from the denominator. But then A is not alone over here. It's out of the denominator, but now I have this delta with it. So how about we divide both sides by that elongation, that delta. That way that cancels. So I'm going to rewrite my formula as area equals FL over E times elongation. And now that I've got it manipulated, I'll go plug in my numbers. So I don't know the area. The force was 8,000 pounds. The original length was 35 feet. I do want that in inches. So to convert that to inches, I'm going to multiply by 12. So I'll just put that there. That's 35 feet times 12 inches in each foot. So this will become inches. The modulus of elasticity was our 30 million. And the deformation was the 0.266. Okay, if you type all this into a calculator and divide it, you're going to get an area of 0.42105. That's how far I took it out when I did it for right here. I'm not going to worry about rounding until, rounding to the precision they asked until I get to the very last calculation. So area is equal to pi r squared, right, of a circle. So if I take this 0.42105 and say that is pi r squared, then it's 2 steps to solve for the radius. Step 1, divide by pi. Step 2, take the square root of both sides to get rid of the square. So I've got r is equal to the square root of 0.42105 divided by pi. Order of operations, you would divide this first, figure out the inside of the radical, and then take the radical, square root. And when you do that, you're going to get 0.36609. At the very end, they ask for a diameter. A diameter is simply double the radius. So if you double the radius, we find out that our diameter is 0.732 inches. There we go. And that is what they asked for number 5.